in ij form. So we'll start with what we'll be covering. At the top right hand corner we have two vectors. The vector A is 2i plus 3j, the vector B is equal to minus 3i minus 3j. We need to deal with what the I and the j actually represent, and when you're dealing with vectors you need arrows over those letters. So the I and the j always have arrows over them, and to say that the thing A, which is 2i plus 3j, is equal to a vector, we put an arrow over that as well, and that arrow is directed to the right. Okay, so the first thing we'll do, we'll plot the vector A and the vector B on the ij plane. And the ij plane is just like an xy axis, but instead of x, we have an I vector, and instead of y, we have a j vector. In other words, I is the horizontal, j is the vertical. 2. Explain the meaning of the I and the j vector. 3. We want to calculate the magnitude and the direction of vector A and vector B. 4. We want to add and subtract vectors. And 5. We want to multiply a vector by a scalar, or just a number. And examples of scalar multiplication are given in number 5. 2 multiplied by the vector A. And the second one, 3 multiplied by the vector A is a scalar multiplication, and minus 2 by the vector B is a scalar multiplication. And we'll check back to make sure we've completed all of these at the end of this video. So let's start with the vector A. The vector A is actually made up of two perpendicular vectors. The first vector is 2 units in the I direction, and then the second vector is 3 units in the j direction. That's why we have the vector A is equal to 2i plus 3j. So to find out what A is, there are two ways of doing it. I'm going to look at the first sentence there on the right hand side. We're going to take a look at the two components. So we're going to draw, starting from the origin, a vector that's 2 units to the right in the I direction, and that's being drawn there in the image. Following on from that, then we're going to draw a vector that's 3 units in the j direction, and j is vertical, and plus 3 means we're going to draw it up. So we get something like that. Now, the vector A then is the resultant of the two of those. So if we were to draw a single line from the start of those two vectors to the end of those two vectors, that would be the vector A. Just like that. So the red vector there is the vector A. So we can see that the vector A is made up of two components. 2i means we're talking about a horizontal component, 2 units to the right because it's plus 2, and the 3j tells me I'm going 3 units in the j direction, and because it's plus 3 we're going up. And then we just draw A from the bottom to the top. Now that's one way of looking at it. The second way of looking at it is you can think of 2i plus 3j kind of like 2, 3 points wise. So in coordinate geometry it'd be 2, 3. And what that means then is you need to draw a vector from the origin to the point 2, 3. And that's a quick way of drawing it. Okay, let's have a look at the next one. Sorry, the vector is made up of two perpendicular components, really important, an I component and a j component, and I just draw your attention to where I've drawn those in the diagram there as well. So, vector B. So we start at the origin. Vector B says we want to go minus 3 in the I direction, so that's left 3 units horizontally, and then after that we follow on with a minus 3j. So minus means down from there, and then 3 units vertically down. So we have two vectors, one to the left and one down, they follow on from each other, and then the resultant of that is the B vector. So that's one way of looking at it. The other way of looking at it, as in coordinate geometry, is that's like we have a minus 3 point, and then we draw an arrow from the origin to the point minus 3. That'll be the blue vector. Right, moving on. Magnitude and direction of a vector. Well, let's start with the magnitude of A. If you look at the vector A, there are two components there. There's a 2i and a 3j. And that makes up a little triangle. The horizontal is of length 2, the vertical is of length 3. So to calculate the magnitude of A, which would be the length of that red vector, we could just use Pythagoras. And that's exactly what we do. So if A is equal to 2i minus 3j, the magnitude of A is written as A with the arrow to represent the vector A and two parallel lines either side of it. It's just going to be the square root of the thing in front of the I squared plus the thing in front of the j squared. You work that out as minus 13. Let's have a look at that for B. So B forms a triangle as well between the vector B, the I component, and the j component. The I component is minus 3, the j component is minus 3. So to get the magnitude of B, we will use Pythagoras, which is the square root of minus 3 squared plus minus 3 squared, which is root 18. Okay, that's the magnitude done. If you look to the right, we can see that to calculate direction, we use the inverse tan. And again, we use the fact that we have right angle triangles in each case. Okay, so I use inverse tan for the direction. So the angle is A, and it's what we're going to do is always calculate the acute angle that the vector makes with the horizontal. So the acute angle the vector makes with the horizontal is the angle A in this case. And the tan of A will be 3 over 2. So A is equal to the inverse tan of 3 over 2, and the direction there is in the box at the end of that snippet. What I want you to remember though is we always take the positive values in front of the I and the j. They just happen to be positive here, so we don't need to deal with that. The other thing I want to say is in the snippet at the bottom where it says E, or east, inverse tan of 3 over 2 north, the east and the north then are easily obtainable from the component vectors. So if we go back to the origin, the thing that comes first out of the origin is the eastwardly vector. That goes in front of the angle. And then the second vector that follows on from it is the northerly one that goes after the angle. So the east comes from the fact that the I component is drawn first. The north comes from the fact that the j component goes second. Also, I would expect you to be able to work out the inverse tan of 3 over 2 on a calculator and put that in degree form. Let's see what happens for B. So we're going to take the positive value for B. Okay, so the angle B is identified there. Again, it's the acute angle that the vector makes with the horizontal. And we have an opposite of minus 3 and an adjacent of minus 3. And remember what I said, take the positive value in front of the I and the j. So B will be the inverse tan of 3 over 3. So plus 3 over plus 3, which is the inverse tan of 1, which is 45 degrees. Now when you want to put the west and the south on it, look at which vector you've drawn first. We've drawn minus 3i, that's going westerly, so that goes in front of the angle, and the south was drawn second, so that goes after the angle. So there are 3 possible ways of writing that: west inverse tan 1 south, or west 45 degrees south, or southwest. Okay, we're almost there. Adding and subtracting vectors is very straightforward. Look at the box. You just add the i's together if you're adding them, and you add the j's together if you're adding them. Or if you're subtracting vectors, you just subtract the i's and subtract the j's. So go beneath the box where it says the vector A plus the vector B. So basically I've just written down the 2 vectors, I'm adding them together. The second line down says 2i plus 3j minus 3i minus 3j. Add the i's together. Algebraically, 2i minus 3i is minus 1i. And then do the same with the j's. 3j minus 3j is 0j, which can be written as just minus I, or minus 1i, or minus I plus 0j. Now when you subtract them, when we write that down, the vector A minus the vector B is 2i plus 3j minus bracket minus 3i minus 3j. And the minus needs to be multiplied into the bracket. Just like when you're dealing with x's and y's, you multiply minus by the first term and minus by the second term. And then we get 2i plus 3j plus 3i plus 3j. Add the i's, add the j's, 5i plus 6j. Okay, multiplication by a scalar. So look in the box. Just like with multiplication of a number by x and y, we distribute the multiplication across the I and the j. So 2 times the vector A is the same as 2 times 2i plus 3j. And then we just multiply the 2 by the 2i and the 2 by the 3j. That's it. 4i plus 6j is the answer. And then there's a little bit of a question at the end. What would 3 times the vector A be minus 2 times the vector B? Well, instead of the vector A and the vector B, we'd put in their components. So 3 times 2i plus 3j minus 2 times minus 3i minus 3j. The multiplication is distributed across the two terms. 3 by everything in the bracket there is 6i plus 9j. And then minus 2 by everything in the brackets there is plus 6i plus 6j. Add the i's, add the j's, gives me 12i plus 15j. Alright, so what does scalar multiplication mean? If we have the vector a on the left, the vector 2a is just that vector in the same direction but twice the size, and that's the one in the middle. If we had the vector minus 2a, it would be the same size as the vector 2a, but the minus says it goes in the opposite direction. So all three are parallel. A, 2a, 3a, 4a, any constant multiplied by a will be in the same direction and parallel to a. And if there's a negative there in front of the a, or a negative in front of the 2a, or minus 3a, minus 4a, it'll be parallel to the other ones, but in the arrow will be pointing the other way. Okay. What does vector addition mean? So if you were to explain what vector addition means, you would start with the first vector, which in this case is the vector a, then continue on with the vector b. So I've got two vectors, a and b, and what I'm going to do is continue one on from the other. So we start from the tail of a, we go to the tip of a, and then from the tip of a, we continue on via the tail of b to the tip of b. And then to get the vector a plus b, you'd have to get the resultant of those two vectors, which is that. Okay, finally, gents, time for you guys to apply it. So I'm going to stop the video here. You can pause it and do the questions.